Now that you know how to create a node and how to interact with them through topics, let's go to the command line and do some practice with the package Turtlesim. Before diving into it, make sure to subscribe to the channel if you want to have a one-to-one discussion on your ROS application. And now, let's get started. If you wanted to practice with robotics, especially with robots that move around the environment, it is always a good practice with the Turtlesim package. But why a turtle? Well, this turtle and this package allows you to perform a few basic functions like go forward, go backwards, rotate by a given angle, and so on and so forth. All these basic functions can be triggered simultaneously and allows you to follow a complex trajectory. The package Turtlesim belongs to the ROS environment, and it is very useful if you wanted to test some nodes that you have written, or you want to test topics, services, and actions. For now, we are just going to do some practice by teleoperating the turtle in their environment, and you will learn how to get some information about the node and topics that are running. Let's say that playing with the turtle is a good exercise to connect the dots of what you have learned so far. To start, let's run the ROS master by typing ROS core in a new terminal. Then, open another terminal and run the Turtlesim node. You can find it in the Turtlesim package. So let's type ROS run, the name of the package, that is Turtlesim, and the name of the executable file contained in this package, that is gonna be turtlesim underscore node. And there you go. Another window pop up with the turtle in the middle. Now we want to command the turtle somehow in the environment that is already created. And to do that, we are going to use the arrows of your keyboard. If you want to teleoperate the turtle with your keyboard, you need to run the executable turtle teleop key node. So, as always, open another terminal and type ROS run turtlesim. And now, since that I don't remember the exact name of the executable file, you can get the help of the tap function to see what are the executable file available in this package. So after Turtlesim package, type tap and we are going to pick Turtlesim teleop key. Now, if you press your arrows keyboard, you can make your turtle navigate in the environment. Let's see what are the nodes that are running now. And to do that, it's very easy. You just need to type ROS node list. And you can find the ROS out, which is a node launched from the ROS master, and then the node teleop turtle that is responsible for tracing a trajectory in the environment given errors. And finally, we have the Turtlesim node that is providing the environment itself. Let's see now what are the topics that are running. And to do that, you just need to type ROS topic list. And here we have ROS out and ROS out edge that are provided by the ROS master. And then we can see that we have 3 topics available under the Turtle1 namespace. And what we have? We have the command val topic that is responsible for moving the turtle, and color sensor that set the color of the environment. And finally, we have the topic pose that shows you the position in X and Y of the robot in the environment. There is a drawback in the ROS topic list. This function doesn't tell you what is the node that is publishing to that topic and who is subscribing to. To figure it out, you should type ROS topic info and the name of the topic. So let's get some information on the command val topic, for example. And we can see that this topic is of type geometry message twist. So the twist is a message that is belonging to the geometry message library. The publisher for this topic is teleop turtle node, and the subscriber is Turtlesim. You can visualize this type of info by running the RQT graph, and it gives you the same type of information. Something very useful to do for testing is to publish on a certain topic from the command line of the terminal. So let's give it a try. Open a new terminal and type ROS topic pub, that stands for publish, then -1, that stands for I'm gonna publish for one time, and then the name of the topic you want to publish to. Then, if you type tab from your keyboard, in the terminal will be displayed the type of the message itself. In our case, the command val topic is of type geometry message twist. And you can see that this message is composed by 2 vectors of 3 arguments each. 3 for linear velocity, x, y, z, direction, and 3 for angular velocity, x, y, z. In the last video, where we have created a node and communicated between each other, we have passed the message of type standard message string. So that's why that we simply need to type a string message. This time, the geometry message twist has a particular structure and it is composed in such a way to have 6 arguments to define. ROS has a lot of messages predefined, and the geometry message twist is one of them. You can develop a new message from scratch, but we will cover this topic with a specific video later on in this series. Here, I just wanted to highlight how messages are differently structured to better describe a certain data. It can be just a string of you wanted to display something, or it can be 2 vectors of 3 components each for a linear and angular velocity to describe how an object is moving in the environment. Let's change the linear velocity x equal 1 and type enter, and you can see that it's moving forward for 3 seconds. If you do it again, but this time changing the angular velocity in z and keeping the linear velocity x at 1, it's starting to draw a circle. Now, let's see in real time the value that are published on the topic Turtle1 Common Val. And you can see that the value are updating while we are using our error for teleoperating the turtle. That's all for today. If you think that you got value from this video, subscribe to the channel and turn on the notification so you won't miss the next video where we will deal with services. Thank you for your attention and see you in the next video, and don't forget to keep learning with Ross.